How's everyone doing today?
Great.
Great. Wow. I know you're lying because it's just lunch. Everyone should be sleepy right now. But anywho, so it's at least good to know you're doing well. Couple of things before I get started. First thing is, I want to make sure my t-shirt and everything is good because it's going on YouTube live. So good? Okay, yeah, that's good. Yes. Secondly, I have really thick Texas accent. So in case you're not able to understand anything I'm saying, yeah, please feel free to shout out and then I'll repeat what I'm trying to say. Man, and also after just having a talk after Jason gives a talk, yeah, sets the expectation really high, right? So yeah, hopefully you get something out of this talk. So a couple of questions also I wanted to ask before I get started. So first thing, how many of you think, how many of you are confused with terminologies with AI, neural networks, what machine learning is, and how it applies to software testing? Great, great. Okay, that's good to know. Okay. Second question, how many of you think in another 3 years, AI-powered robots are going to take over the world and we're going to be slaves to them? Okay, yeah, see? Yeah, that's cool. So I have some good news and some bad news. Good news is I have the answer to the first question. I am going to talk about how AI is influencing software testing, and you're in the right talk. Bad news is I don't have the answer to the second question, but the next Terminator movie is definitely going to answer that as well. So with that being said, let's get into my talk today. So a little bit about myself. Again, my name is Raj, and I'm a developer evangelist at Testim.io. A couple of sentences about my company before I tell what I do for the company. So Testim.io uses artificial intelligence for the authoring, execution, and maintenance of automated tests. Our focus is on functional testing, end-to-end testing, and UI testing, right? And we are based out of San Francisco, so that's my company. So what I do for the company is I'm a developer evangelist. Yeah, it's a super awesome way of describing my job, but basically I'm jack of all trades, master of none. So I do 30%, I do conference speaking, and I do a lot of writing, which I'm really passionate about. Another 30-40%, I work with R&D to make our tool better. I work directly with customers to see how they're using our tool and make sure, put in features to help them out. And the last 30%, I guess, I know you're following whether I'm doing the math right, but anyways, I don't care. But the point is, the last 30% is, yeah, I do support customers as well for the entire US region. Anything related to technology comes to me, and I work with the founder of my company pretty much to help them out and make the tool better. So that's a long description about what I do. Yeah, I've been in the development and testing industry for over 12, 13 years now, and you can see that I share my ideas on testing regularly on my blog and other channels as well, so you can look at the links and you'll figure out stuff. So this is what I'm going to cover today, right? So first I'm going to start with the basics of AI because everyone keeps getting confused with the terminologies, and I want to explain AI from my perspective because when I got in the AI field, everything was really confusing, right? So I wanted to dumb it down to really simple things for make me understand what it is, and hopefully what I'm going to say also gives you clarity on the terminologies. Then I'm going to talk about what are the current challenges in test automation, how AI can help to solve these challenges, and finally talk about the future of artificial intelligence. So first, let's set some context, right? Even before talking about AI can do this, AI can do that, it's really important to understand how test automation in general has evolved over a period of time in the past few decades. So in the 1980s and 1990s, right, so testing was predominantly manual testing, and yeah, we didn't have any tools or automation, and The development methodology was also basically waterfall methodology, where developers used to work for 6 months and finally build a product, and then it'll come to the QA's testers' hands, and then they'll find bugs, and then they'll send it back, and then you have to fix it, and then send it back, then retest it. So there's a whole thing, right? There was so much time wastage. So that was the 1980s, 1990s era. Then we had 1990s and the 2003 period, right? So we started seeing finally some tools coming out to help the testers. On the bright side, testers thought, man, now we have automation tools to help us out. But on the other side of it, it was a problem, because how many of you have had situations where you were using automation tools and the whole laptop froze? Pretty much you can't do anything, right? QDP, but yeah, so those kind of tools. So the point is, they were really bulky automation tools, right? And then at the same time, people started experimenting with different approaches like RAD, Rapid Application Development, XP, Scrum, and so on, right? Then we have 2003 and 2010 timeframe, where we saw more tools coming up, and then it was mainly the era of open source frameworks, right? We know some open source frameworks, right, because we are at a Selenium conference. So it's like people, like in Selenium, they were group of like-minded people who wanted to solve different problems with test automation. They started involving other people as well, and then build a community, right? So open source was a big thing. And at the same time, we had agile approaches like XP, Scrum, Kanban became a normal thing. Everyone started following, and the name of the game was faster release cycles, how fast you can release stuff to the customer. And then 2010 to current, right? So it's more about scale. So what do I mean by that? We need to run a lot of tests in parallel, multiple times. We want to find bugs faster, we want to release faster. And also during this era, we had cloud testing. You have SaaS Labs and other folks who said, you know what, don't worry about the hardware and software, let me figure it out, you just do your testing. And then we had crowd testing, where there was this group of people who gave their software to the testers and get feedback from them, either paid or not paid version, right? So those were the two major things which happened. And then we keep hearing about DevOps, continuous testing, CI/CD, which is kind of normal right now, from 2010 to the current state. Now we're going to talk about the future, right? The future is going to be about autonomous testing, machine learning, and it's from my point of view, it's going to be about dynamic locators, which I'm going to talk about in detail in a bit. And it's all about smarter testing. So that's the name of the game. And that's, my point of view, going to be the future. So I just wanted to give that context before we actually talk about AI, software testing, test automation. So first thing I want to start with is some basics of AI. My goal is by the time you leave the session, at least you'll have some idea on what different terminologies mean, and then you can have a conversation about it. So on a really high level, you have artificial intelligence, right? So what is AI? AI is the area of computer science that deals with giving the machines the ability, building machines which can think and work like human beings, right? So that is artificial intelligence. Under artificial intelligence, you have machine learning, which is a subset of artificial intelligence. And it's a field of study that deals with giving the computers the ability to learn without being explicitly programmed. So that is what machine learning is. It evolved from the study of computational theory and pattern recognition. Computational theory was pretty much study of learning algorithms, so that's how machine learning evolved, right? So that is machine learning. And then under that, you have what is called deep learning, which everyone now talks about. So deep learning is just one of the areas of machine learning. You have Bayesian networks and inductive logical programming and so many other subsets of machine learning, but deep learning is just one of them, right? So what is deep learning? So deep learning is basically a model based on the neurons of the human body. So in our human body, we have neurons. Each neuron starts learning from another neuron and starts reacting and reacting, and we act according to all these interactions in our human body, in the neurons, the neural network, right? And they just took that to the field of computer science, and that's why it's called a neural network, because it's mimicking the human body neural network, right? So deep learning neural networks, so they use it synonymously. So that is what is deep learning. And just to give you an example of what people do to train AI or machines to learn, right? You have heard about all these things quite a bit, but I just wanted to dumb it down to a really high level, right? So say you move to Chicago and you're trying to find a place in Chicago, right? And then you build a neural network for it. So the way you may go about doing that would be, say you give the size and the price of the house, and then you want to see what happens, right? So the size and price, the input, the combination you give is called a training data set. So a training data set, that's what they keep calling it. So say you give the size and price of the house, right? And then you think about, let me give the number of bedrooms I want, right? Because that could also depend on where I live in Chicago. And after that, probably, after giving the number of bedrooms, probably the AI would figure out family size is something is really important for you. You know what? So let me look at areas based on family size. Next, you can give zip code and the price, right? And then it could figure out maybe how walkable the area is, right? So that is something it may start building that relationship. And then you would give wealth and the price, right? It probably could figure out what's the school quality. School quality is something important for you, so let me try to give you data based on that, right? So whatever happens here and here, right, out in the outside, so those are the training data sets we give. But all these relationships, the family size, the walkability, school quality, all these things are done by the AI in the black box, right? It's like a black box. So this is basically how they in general, how they train the AI, right? So I just wanted to give you an example. And then when we talk about deep learning, they usually talk about three things, right, under deep learning. So one is supervised learning. So what's supervised learning? Supervised learning is you give different training data and then make the machine learn and then monitor it and see how it's doing, right? So a lot of examples for supervised learning. For example, how many of you have this experience where you're using Hulu or Netflix, and then once you log in, then it gives you recommended movies or TV shows, right? So those are all, that's because you have an AI, an algorithm which actually does that based on a viewing pattern, right? So that's an example for supervised learning. And then giving audio and getting text from it. So that's an example. Then giving a bunch of emails and then seeing which is spam, right? So those are some of the things are good examples of supervised learning. And of course, you have autonomous cars as well. That's a great example for supervised learning as well, right? Then you have unsupervised learning. So that is giving a bunch of data and then see what the AI can come up with, right? And some examples could be cellular companies like AT&T and Verizon, right? They want to target different states based on age group. Like they want to give targeted ads for 16-year-old people to targeted ads for 80-year-old people, right? So market segmentation is something where unsupervised learning is being used. And then you can give an image and create a 3D model of it as well. So those are some examples of unsupervised learning. Then finally, you have reinforced learning. That is basically the concept of rewarding good and bad behavior. So it's like training a dog. You'll give something and then you get some output and say, bad dog, bad input, right? And then next time you give another set and then you say, good input, good, right? So you just keep training, and that kind of example, reinforced learning. Again, I'm trying to simplify all these concepts. So those are pretty much the things you want to know about AI. And now, in terms of autonomous cars, for example, for the past 3-4 years, they became really famous. But the first research, for example, for autonomous cars was done in 1989 at Stanford, right? We just don't know about it, right? So I know looking at your faces, you're skeptical and you don't believe me. So that's why I have a video to show you that autonomous cars, this video was released in 1982.
Alvin is a system of artificial neural networks that learns to steer by watching a person drive. Alvin is designed to control the NavLab 2, a modified Army Humvee equipped with sensors, computers, and actuators for autonomous navigation experiments. The initial step in configuring Alvin is training a network to steer. During training, a person drives the vehicle while Alvin watches. Once every 2 seconds, Alvin digitizes a video image of the road ahead and records the person's steering direction.
And again, this was in 1992. So this was their experimental car, Alvin, and they're training it, right? And you'll see more cool stuff happening.
32 pixels and provided as input to Alvin's 3-layered network. Using the backpropagation learning algorithm, Alvin is trained to output the same steering direction as the human driver for that image. Initially, the network steering response is random. After about 2 minutes of training, the network learns to accurately imitate the steering.
Oh, sorry. That was my bad.
Alvin is a system of artificial neural networks that learns to steer the most confident network. In this case,
so what's happening is they're feeding it images and training it, and then at one point, at this point, once they feed all the images,
and Alvin begins driving.
They put in autonomous car mode or whatever, it starts driving based on the data you
12
already
times
fed
per
it.
second, Alvin digitizes an image and feeds it to its neural networks. Each network, running in parallel, produces a steering direction and a measure of its confidence.
So this is a confidence level in terms of how confident it is, it can perform an action. So this is really important because it's going to make sense when I actually relate it to testing.
The steering direction from the most confident network, in this case, the network trained for the one-lane road, is used to control the vehicle.
Now let's get to some interesting part. So it's coming to a junction, right? And now see, its confidence level will decrease because it doesn't know how to react.
As the vehicle approaches the intersection, the confidence of the one-lane network decreases. As it crosses the intersection and the 2-lane road ahead comes into view, the confidence of the 2-lane network rises.
It starts increasing again.
When its confidence rises, the 2-lane network is selected to steer, safely guiding the vehicle into its lane on the 2-lane road.
There you go, and the car drives and everyone lives happily ever after. But the point is, so this autonomous cars and all this AI stuff which you're hearing, the research was done a while ago. It's been happening, right? We just now come to know about all this stuff, right? So I just wanted to show you stuff. And just one more last thing I wanted to show you is a lot of people when I was speaking at conferences ask me, hey, can you show visually me training an AI? I want to get that experience, right? So I was thinking about different ways to do that. I found a really good way to show you how a training an AI would look like. So we have, one second, hold on. So we have an open source website called Quick Draw by Google, where millions of people draw different diagrams based on what the AI suggests. And then we are training the AI by drawing different things, right? It'll start predicting. That's a really good example of training an AI. So just want to show you, for example, how it works. So this is how it works. Now draw a bandage in under 20 seconds. So let's see. I'm really bad at drawing, but.
I see line, or ocean, or canoe. I see skateboard, or shoe, or spoon, or crocodile. I see hot dog.
No, so.
I see river. I see submarine, or belt, or flying saucer, or frying pan. I see helicopter, or toothbrush.
So,
Sorry, I couldn't guess
okay,
it.
so I fail on that. So let's try another one. So let's try panda. Okay, I think I should be able to get panda. Let's see.
I see circle or blueberry. I see frying pan or shoe or watermelon or teapot. I see snowman or alarm clock. I'm not sure what that is.
I don't know.
I see koala or bear. Sorry, I couldn't guess it.
Oh man, I need to get one. Okay, skyscraper. I think I should. At least I should get skyscraper. Come on, man. Let's do
I
this.
see line or broom. Oh, I know, it's skyscraper.
See? Yeah. Okay, let's just do one more. A crown.
I see fork or arrow. Oh, I know, it's crown.
Right? Okay, let's just do one more. I know it's addictive, right? So, okay, it's a necklace.
I see paperclip or garden hose or roller coaster. I see blueberry or ring or lollipop or person.
Hold on,
I see satellite or yoga or hula hoop or flamingo. I see sun or short monster or fan or tree. I see leafy
But
tree
anyway,
or
so
garden or cow
I thought
or
I could be
flower.
smart,
Sorry,
but
I couldn't guess it.
But anyways, so this is a live example of actually training in AI, and I just want to show you how it actually looks like. So yeah, two things we learned from this exercise is now you got a visual image of how it will look like. And second thing is I'm really bad at drawing. Now I admit it in front of everyone, right? So those were basically the things related to basics of AI I wanted to cover. Now let's get into the real deal, right, with test automation and the challenges and how AI can help to overcome those challenges. So recently, we did a survey in terms of how fast teams release software. The highlights of the survey was 57%, a majority of the people said they started testing really early, but just kept testing, and then they missed deadlines, and they couldn't release at all, right? How many of you have been in that situation, right? Most of us, right? And the same thing happened in the survey as well. And only 2% of people really deployed every minute of every day, right? So why is this? So once we started analyzing why this problem was, we figured out there were 5 set of challenges which people face currently with test automation, right? And those are the things we really need to think about. So let's first talk about skill set, right? So getting skilled testers is expensive and hard to get, right? And usually many companies suffer with not having skilled testers who can do automation as well. So that affects release cycles, right? So the skill set is a major problem which are affecting release cycles. Then you have authoring. So now we have hired skilled testers, and then they start authoring tests, but they fail to pay attention to good practices of automation such as reusability, how to do parameterization, how to do data-driven testing, giving optimum weights, right, reusable weights. So those kind of things people forget, and that in turn also affect releases because they don't release until all automation tests pass, and then because you have problems with authoring, you never seem to release on time. Next challenge is the initialization states, right? So what do I mean by that? Say you're automating a web page, say like Amazon shopping cart, right? You write an awesome automation code to actually add items to a cart. So you write your automation code and it adds an item to the cart, right? You're super happy. Then you run it again. What happens, right? You forgot to initialize, bring it back to the initial state of 0, right? Because every time you're going to run it, it's going to start 1, 2, 3, 4, keep increasing, right? Those are common problems which people fail to realize, like setup and tear down activities, right? So those are things which are affecting test automation as well. So next one is maintenance, right? The biggest problem with test automation, and it's been the same case for the past 20 years, is the maintenance, right? So say you have 10 tests you wrote, and then you're super happy it all passes. Next day you come to work, and then everything fails, right? Because the state of the application has changed right now, and then you have to spend a lot of time maintaining it. And based on a recent survey, 30 of a tester's time goes into just maintaining automated tests. That's crazy, right? Imagine the amount of stuff you could do in that, even if you shave off some percentage of time you spend on maintenance, right? So maintenance has been a really big challenge. And finally, scale. I know I talked about scale in terms of resources like cloud computing and cloud testing services, but another thing in terms of scale is your automation suite, right? How scalable it is. Is it, could you add more functionalities to it? Could you extend the functionalities? And can you run more tests in parallel, faster, right? So those are some of the things you want to think about. So these are the 5 main challenges which exist currently in test automation. And so that's why we probably need AI for some of these. And then I'm going to tell you about how AI, to a certain extent, can overcome these challenges, especially the maintenance piece, which is the biggest challenge especially at Testim. That's our goal. That's what we are trying to solve, right? So that segueing into the next section. So now I discussed the challenges, so let's talk about how AI can solve these challenges, right? So at Testim.io, where I work, we use a concept called dynamic location strategy, right? And from my point of view, I think that's going to be the next big thing and future of test automation. So what do I mean by that? Say you have a login button on a web page and you change the name of login to submit, and for some reason say you're locating that button by name, the login name. And if a person changed the name from login to submit and you run the automation code, what happens? The test breaks, exactly, right? And as testers, what we do is, okay, man, the test broke. Okay, now let's see what happened. Oh, okay, the name changed. Hey, developer, the name changed. Please change name. Oh, no, I'm on vacation for 2 weeks. I can't do this, right? And then you go to another developer. There's so much wastage of time and the maintenance piece, right? It's been a really big problem because you're using one single location strategy for every element. For example, the login button, you're using the ID or the name, right? And with dynamic location strategy, which that's why we are using AI for it, is getting multiple attributes for every single element you interact with, right? So what happens in real time is we have this AI underneath the hood, which extracts all the object trees and properties of the element of the DOM, and then creates a list of location strategies, right? And for the same example of login name changing to submit, if we are using dynamic location strategy with the AI, it won't break, because what's going to happen is it's going to say, oh, the name changed. You know what? I'm not going to fail the test because the functionality hasn't changed, but yes, the attribute has changed. But let me go to the next best location strategy. It'll go to the ID. If the ID had changed, it'll go to the next best location strategy. It could be class name, the next best location strategy, tag name, parent-child relationship. So it'll go through the entire location strategy list, which is it has extracted in real time, right? So that is called, this is a concept, and it's called dynamic location strategy that is getting multiple attributes. So that's how you can actually help in maintaining and creating more stable tests. And more tests you run, the AI keeps seeing what now is happening, and the tests become more stable because it finds different ways to optimize your tests, right? So just to show you the concept of dynamic locators, I just wanted to show you a demo. And different people implement dynamic location strategy in different ways, but I'm just showing you what we are trying to do. So so I have a test, and just let's quickly record a test, right? I just created a sample web page just for demo purposes. I'm going to type in name, password, and then select dates from, say, a date picker, and going to go ahead and book this itinerary, and then enter a name, email ID, and yeah, I think that should be good for now. So I just quickly recorded a test, and then yeah, let's just make sure I didn't mess up anything. Live demos always are successful, right? So don't worry, I also have a recording of this, so in case this bombs, I have a video for it. But let's give this a shot first. So just going through the steps I just recorded, selecting dates from a date picker, selecting a button, clicking on book. Cool. Seems like the test will pass. Okay. Cool. So the test completed successfully. So remember the dynamic locators which I was talking about? So this is how it works underneath the hood. So say, for example, you take the select destination button. And here you can see all the attributes which have been extracted for that particular select destination button, and it's displayed over here. So you have the text attribute, tag attribute, class attribute, and so on. And remember, I showed that autonomous car video. You thought that I was just showing off with videos, but there was a purpose, because if you see over here, you have the confidence level. So it says 100%, which means that when I ran the test with 100% confidence, it said I can locate that select destination button. And then for each attribute, you also have a scoring system. So for example, say this text attribute, right? It has a score of 0.9, which means that that's the best way it thought it's going to locate that element. Say if the text attribute changed, then it'll go to the next best location strategy based on the score. It could either be the class or type attribute maybe, because both have the same score. But again, all those decisions are made by the AI underneath the hood. We don't have to worry about it, right? And to show you how dynamic locators, the beauty of dynamic locators and how they can make your test stable. So in real time, I'm going to do a change and let's see what happens, right? So I'll just put a breakpoint quickly. And again, this mainly to show you the concept of dynamic locators, and this is how we implement it. So what's happening is it's just running through the test until the point I click on the select destination button, because I put a breakpoint. Cool. So it reached a breakpoint, right? So what I'm going to do is, let's do an inspect. Man, the screen is so small here, and I'm pretty much blind. Okay, let's say we move this button, right? So I've moved the button, the select destination button over here, right? You're seeing it. And you know what? To go one step further, let me say SeleniumConf Chicago, right? Okay, so if this was any other automation framework which we have right now, so what's going to happen if I continue running the test? It's going to break because the location has changed and the name has changed, right? But now, because of the beauty of dynamic locators, so this, let's see what happens. If I did everything right, if I play, there you go. So the test still continues to run. And yeah, so test will pass. So this is the beauty of dynamic location strategy, because the attribute changed, but the functionality still remains the same. So why do you want to fail the test? The thing you could do is show that, hey, there's a change. So for example, the way we do it is, if you look at the screenshots, for example, it says that, hey, I expected the select destination button, but what I found was SeleniumConf Chicago, right? So it tells you that, hey, there's a change. But the functionality didn't change, so it still kept continuing to run. And if you go back to the locators again, so if you notice, now it's 83% confidence, because I actually changed an attribute, right? Similar to training that car. And also, if you see the text attribute over here, oh, okay, it's really, for people in the back, you can see it. But if you see the text attribute, there's a color coding there showing that that attribute has changed. So what have happened in real time is it went to the next best location strategy, which could either be the type or the class. Again, the AI does it for you, right? So this is how dynamic locators work, and a lot of people are currently working on it, and this is how we implement it, but I showed you the demo mainly to explain the concept to you, right? So that's going to be the next big thing. This diagram is from a person I know, a person named Jason Alvin. So I really love this graph, because as the test coverage is growing linearly, right? What's happening is the complexity of the software has been increasing exponentially, and there's this coverage gap, right? And that's what we are trying to focus on with AI-based testing. So that is something to keep in mind. Now let's talk about the future of AI, right? So some of the things I'm showing you are things which we are currently working on and things which are possible because of AI, right? And this is going to give you an idea about how AI has been going to be used in software test automation. First thing is autonomous testing. So you no longer have to assume how the user is going to use your apps in production, right? So what we could do is, we have this AI actually looking at what you're doing in live production, and then based on that, it's going to start finding out patterns in terms of common things people are doing. Say, for example, again, come back to the login button scenario. Say you have this login page, and you logged in 50 times and logged out 50 times. The AI, based on this production, looking at the production behavior, it would say, you know what? You logged in 50 times and logged out 50 times. Why don't I create a reusable component for it, right? So it's going to create a reusable component and automatically inject that into your test, right? So it's going to start authoring tests based on your production data, right? So you no longer have to assume things, but you're going to have already written tests based on user behavior. So next is UI TDD. Yeah, we have heard of BDD, TDD, ADD, SDD, or whatever, all the DDs you have. Just to make things more complicated, we're injecting one more thing called UI-based test-driven development. So what do I mean by that? So yeah, I worked in the industry for 14 years now. Yeah, based on my experience, this is how usually development works, software development works, where you get design mocks, and then based on the design mocks, the developer will know what feature to build, then he starts building the feature, right, based on the mocks. That's how I'm used to. So now with UI-based TDD, what you could do is, when you have the mockups, right, so the developer can look at the mockups as and when he's starting to build a feature. You can use the AI and recognize all these images, and based on the images, you can start creating tests, right? So what's eventually going to happen is, by the time the developer has completed building the feature, you already have tests written, and then you can run the test on the build feature and see what happens, right? So that is UI-based test-driven development, and that is something which is coming up and something to keep in mind. Next is automatic responses, right? So when you're doing UI-based testing, quite often people have this problem. So how many of you had this problem where the same test, when you run it, sometimes the page takes 3 seconds to load, sometimes take 15 seconds to load when doing UI testing. Exactly, right? So the point is, because of that, what happens is then you have to start looking at what optimum wait statements to give, what's happening, and all that stuff. But now with AI, what you could do is, the AI is going to recognize that, dude, for the past 50 times you tried to log in with the same credential, raj@testim.io, right? And every time the response goes to a server and comes back, and because of that, the pages load late, and because of that, your tests are failing. So what I'm going to do for you is, I'm going to record all these responses within myself, right? And then whenever you want to log in, I'm just going to relay it. So you don't even have to go to the server for the request. So you can just record all the server responses and then give it to the user UI test. In that way, your UI testing is much faster and much more stable, and you don't have to worry about these timing issues as well, right? So that is something you're actually currently working on as well, and something is going to come up. So how Testim is paving the way for the future, right? So it's easier for QAs now to maximize user coverage, right? So the point is, you're already creating user scenarios based on production data, so you already have a lot of user coverage, right? Now, QA is now like it's just more than just QA is like a science right now, because you're making all the decisions based on data and risk-based approach to testing, right? So that's something which you can achieve with use of AI, and you're preventing bugs as opposed to fixing them. So what I mean by that? So with AI, you have the self-healing mechanism. So what that means is, as and when you run the test, the AI sees what all things you're running and becomes smarter and smarter and starts optimizing different things, especially wait times, right? How many people have to put explicit, implicit waits with, like say, for example, Selenium, right? Or any other automation framework, right? But now the AI can start optimizing all those waits, and you don't even have to do that anymore, right? With the help of AI, you can overcome that issue as well. So those are some things you can expect with AI when you use it for software testing. So yeah, that's pretty much what I wanted to cover today. My goal was to give you an idea from my point of view what AI means and what we're working on, what you can expect as in the future. And I've given a summary of my talk, written a post about it in this link, and you can find all resources and extra things which I mentioned. And yeah, you can look at it at your own time. So yeah, that's pretty much what I had. Thanks for coming. Thank you.